All right, how's everybody doing tonight? Hope you guys are good and ready to learn some generative AIs. Still have some energy. I'm happy to present evolution of tool use and MCP in Gen AI. And yeah, let's get started. So a little bit about me. My name is Gautam Baghel. I tell people my name is like Gotham City from Batman. And I'm a senior product manager at HashiCorp at IBM. Specifically focused on MCP and Gen AI workflows. If you'd like to connect with me, that's my LinkedIn. So today we're going to be talking about, just evolution of Gen AI in general, and we'll get into MCP, what it is, why you should care. I want to give you some lessons learned and what we kind of saw from, building the Terraform MCP server, which is quite popular now. Why MCP is better than just using vanilla LLMs or something like ChatGPT. And then we'll see some live demo, hopefully praying to the live demo gods, and yeah, we'll go from there. So getting started, a lot has happened in the past 2 years. I mean, it's such a, for those of us who've been keeping up with all the changes in technology and this AI race, we've kind of forgotten how we evolved to this place, right? Like there's so much that has happened. So before I kind of talk about evolution of tool use, I'd like to talk about evolution of AI in general. Um, so we started off with early rule-based system, the helpful assistants, like you could ask it questions, and it essentially worked as a sort of a conversational Google search, more or less, right? Then we went into sort of more analytical skills by the large language models and that step-by-step reasoning that it came to break down like bigger problems into smaller chunks. Then the issue was, okay, it's great that I can look for public information that the model is trained on, but how do I give it access to my private data sources? Like, how do I give it access to, my internal Confluence pages or PDF documents that I have, static documents do I have? And that's where RAG came into the picture, right? Retrieval augmented generation. Really took all of your documentations and vectorized it in a vector database, and that way when you asked a question it knew the context about those documents, right? Then as models evolved, they grew the ability to use tools and execute tasks, and do things like function calling, right? We needed some way to widely adopt this capability. I think tool use was pretty powerful, but there wasn't any easy way to describe your tools and have the AI model kind of use those tools with your workflows. And that's where MCP really shined. It was one, very easy to build, easy to get started, and really powerful in the sense that you can describe what your tools did, and essentially the models will pick up and try to perform or execute that tool. And we'll learn about that a little bit more further down the slide. Then finally, we have the agent workflow. That's the biggest thing right now in the space is, okay, how do you make the agent workflows like more and more autonomous? So that's where we are kind of heading. I use this slide to kind of orient everybody to kind of take through the journey of like what AI has actually gone through. Right? And when you look at using AI specifically for coding, right? Code generation, the evolution has been slightly different. We as a developer want to make sure that generated code, A, doesn't have simple issues like syntax errors, B, are not hallucinated, there's no compile time errors, and performs actions as specified. So that just basically means no runtime errors, right? And with these newer coding assistants like Claude Code, IBM's Bob, Copilot, all these AI assistants make this feedback loop of running something, trying something, that erroring out, and resolving that error. That feedback loop tighter and tighter, right? The AI engine writes something, self-reflects, changes them, and make sure they adhere to your security testing framework and loops back. And it's a very interesting evolution to see, at least in my opinion. It's like kind of changes how what a job of a software engineer will be in the next 3 to 5 years, right? Where they won't focus on like the nitty gritty of like searching code examples, like Stack Overflow, but really defining like outcomes, right? And testing strategy and instructions and so where does MCP and essentially tool calling fall into all of this? So it can be an execution arm, so it can run certain tools for the AI engine that normally it would have hard time knowing how to use those tools. So for example, from simple things like reading a file to complex things like the Playwright MCP that can do browser automation, like take screenshots and debug console logs, right? Or it could work as a better context providing mechanism. So if you have live APIs, there's something that RAG cannot accommodate. Like RAG is meant more for a little bit more static architecture, right? Because you have to vectorize the database, right? If you have an API or an endpoint that changes rather quickly, MCP is kind of more suited for that. So let's do a deep dive on what MCP actually is and how does it work. Here's a quick intro on MCP. So it's an open source project started by Anthropic. That was a little over a year ago, November of 2024, I believe. And the idea is you provide your models with seamless context for your AI, right? And that context is very important when it comes to generative AI, right? And that allows the model to essentially give smarter responses. So what is the difference between using MCP and calling APIs in general? So API are very general purpose. They were designed for software to software communication, not specifically for AI. MCP, on the other hand, was built from the ground up for large language models. It standardizes how LLM fetches context and use tools. In many ways, it is very similar to what Terraform did for the infrastructure ecosystem. If you're not familiar with Terraform, or if you've sort of heard about it, as the HashiCorp's infrastructure as code tool, where you can define, the infrastructure that you want as a simple HCL code language, and it deploys, your resources for you. It's like you can bypass Terraform and directly call the cloud APIs as well. But most of the practitioners don't like doing that because there's a lot of way you can make mistakes. The API changes themselves a lot. Like it's not a great way to adhere to a standard, right? And it also doesn't practice the DRY approach, which is do not repeat yourself. You write that code once and kind of have it shipped multiple times. So MCP did something very similar where it took you can do tool calling via just API calls and to the LLM, but they standardized this layer that's a middle layer, which allowed users to define their tools in a more meaningful way. So there's three main concepts when it comes to MCP. There's other newer things that are coming up in the spec that's being picked on, but as far as I see, there's three main pillars, right? So there's tools, there's resources, and then there's prompts. Very simple way to understand tools is think of them as more like a post request where you want to make changes in a system, right? It's a tool that's making some sort of CRUD operation, right? So that could be retrieval search, create a database, update user info, those kind of things. Then you have resources. Resources are more like GET requests, therefore contextual data or content. So let's say you have a static document, for example, in Terraform, we have Terraform styling guide. That's a static document that tells how should the LLM model, generate better Terraform code, right? So that could be files, unstructured data, static web pages, all those things. And prompts are more like predefined templates. Like if you know what most of your users want out of your MCP, you can define them as prompts. So here's how the core MCP workflow works. So you have on the left-hand side, you have your AI host. This could be a coding agent. So VS Code, with Copilot, you have IBM Bob, you have your MCP server in the middle, and then you have the product, right? Essentially, the AI host sends a very simple JSON request, and we'll see that in the demo. It'll say something like, I need this thing, like it understands how to use the tool. So it adheres to the request query. It says something like, okay, I need the AWS provider. Again, I'm using Terraform as an example. I want to deploy something in AWS and an S3 bucket, and I want to use this version of the AWS provider, right? MCP server will read that and it'll make the API queries. These could be multiple queries or could be a single query. It'll make all those queries and it will get the response from our APIs, from our products. And once the response returns, it can extrapolate that or change that as needed and send it back to the AI agent, right? So MCP really acts like an adapter. Like, there's requests being sent out by the AI host that is acting as an adapter between the product and the AI host. So I want to take a quick mention of the Terraform MCP server and really talk about some of the things that we've seen kind of come up as we ourselves were learning all these technologies and building all these workflows and tools, right? So Terraform MCP server is really purpose-built for Terraform workflows. As a platform engineer, your day-to-day operation that you do using CLIs or bash scripts or anything like that, that can now be automated using a code assistant and the MCP server. And you can simply talk to it like using natural language, just like you talk to a human, right? It also reduces hallucination and increases accuracy because we are fetching live API calls and getting the most relevant schemas. It knows much better about how to build and push and write Terraform code. You can also automate, your daily chore, right? You want to know, okay, how many workspaces in, Terraform Enterprise do you have that need, your attention, like has some, using older modules or something like that, or not adhering to your policies or security standards. Instead of going through the UI, painstakingly looking after hundreds and hundreds of workspaces, or creating some sort of filters or bash scripts to kind of do that, MCP can just do that on the fly. You can keep asking it questions and it can just get you that information. Okay, so here's an example, right? A prompt could be something like, okay, I need help setting up my Azure storage bucket using Terraform. So this is how the Terraform MCP works. So it uses multiple tools to respond to this prompt, right? First thing it does, it searches for all the relevant content in the Terraform registry. Now, there could be multiple documents that might be relevant to this search, right? In order to deploy a storage bucket, for example, you might need to create a resource group, or you might need to have a VPC, which I don't think you need to, but there are dependencies that you might have for deploying on resources. So the MCP server first searches for all the relevant documents, collects information about them, and sends that to the model. Then model says, okay, based on what you sent me, sounds like out of 20 of these documents, only 3 of them is relevant to what the user is asking. So it consults these multiple documents and gets details about them, right? It combines that result and generates that code snippet for them. And this is exactly why it's more accurate, because it's kind of consulting and working with multiple of these documents. Now, as models get better and better, they're getting less and less hallucinated and doing all that good stuff. You might start to question, like, okay, like, I think it's good enough. I don't need to have these kind of special features. But also think about, the practices, the DevOps practices you've established within your company, right? Like if there is a private module that you have, or if there is a private provider that you have, the large language models by themselves don't know about those modules because they're logged behind your enterprise, um, enterprise account, right? And you need MCP to be essentially tell the model that, hey, I have a private module that can, deploy this Azure storage bucket for you that is extremely relevant, and you need to be using that instead of some public resource or public module, right? And that's where MCP becomes really powerful, because it can take what you've built over the years as as your foundations, and supercharge those workflows. So for authentication, right now the Terraform MCP server is a locally deployed server. So you would deploy it in your desktop or your computer as a Docker container, or as a binary. You can also just deploy it as a binary. And you would give your Terraform team token as an input to the MCP server, so it can, perform whatever action it needs to. In the MCP.json, you have the token, the Terraform Enterprise token, that will help MCP authenticate and do the things that you're able to do. It also acts as a authorization boundary. So let's say you don't want your AI agent to perform certain things. If token doesn't have that permission, MCP won't have that permission as well to perform. It will fail. There are other mechanisms we've built into the MCP server that can make sure the agent is not taking actions that you're not comfortable taking. All right, with that, let me actually demo this to you guys. So I'm going to share my screen here, and let's see. Okay, so I have, hopefully you guys can see my screen. Yeah, I have IBM Bob here, and I've already configured my MCP server. So if you go to settings, if you go to MCP, you can kind of see I have my Terraform MCP server already configured here. And so what I'm going to do is I'm going to ask Bob, hey Bob, can you look through my private modules and help me deploy an AKS cluster? Okay, right here. So this is the tool call. So it's searching my private modules, and that's exactly what I wanted to do. I said, hey, can you look through my private modules and help write Terraform to deploy an AKS cluster in this specific org, right? And you can see it's asking me permission. Are you okay running this tool? All that good stuff. And there you have it. And Bob is already kind of working on it. And you can see this module, for example. Let me just save it so that it. Let's press save so that it's a better view. Let's do this. Make it bigger. Let's go back. It's still generating some code. But you can see the module that it used is actually a private module. And it understood how to use the required inputs, how to use the required outputs, and generated that code, including variables and some default values that I've defined in my private module. And yeah, this module is available in my Terraform Enterprise account. So that's where the MCP becomes really powerful, because if you needed to deploy or generate code that requires using your pre-existing setup, you can't do that with like a large language model that's out of the box. And so Bob's going to keep working on it. It's going to keep iterating on it. Hey, here's the vars, here's the main.tf variables, and generates a really nice README for me. This is also taken from the module README that I had defined. So cool. If I need to proceed, I can ask, Bob, hey, could you deploy this for me? Could you run Terraform plan and make sure everything's working and do all that kind of good stuff moving forward? But you can kind of see it generated all that command. So there we go. It finished with the task. Let me make this bigger. Okay, I think that's as big as I can make it right now. Be like, okay, here's the task. It kind of tells me how much token did I consume and do it. And gave like a really nice summary on how I can proceed. Cool. Let me switch back to my slides. Cool. So, you have, in terms of capabilities, these are the kind of tools and resources we've exposed as part of the Terraform MCP server. There's a lot of capabilities around, writing good Terraform code, attaching policies, style guides, module style guides. You also have HTTP Terraform or Terraform enterprise workflows, creating workspaces, runs, logs, variable set. These are incredibly hard to kind of define in isolation. To tell the model to read some sort of API spec and kind of do curl commands on do all that kind of stuff would have been incredibly painful. MCP kind of standardizes a lot of that, right? And one thing we've been focusing and we're learning, more and more ourselves is how do we save, ourselves and our customers some token usage and so token money, because tokens cost money, right? So we've been optimizing these tools to really generate the most relevant content. And in the demo that I was showing, the token burn that happened there was very reasonable in that sense for what it produced, right? And I've been kind of hinting throughout the presentation, like why, using MCP server is better than raw LLMs. I think the training data, specifically between provider versions for Terraform, gets very confusing. Every model that you see, the training that happened to that model was 6 months ago or 8 months ago. There might be new schema available. There might be new providers available. So querying those live APIs is always going to be more accurate, right? MCP also gives better recommendations in general, because it can search and give model access to like a bunch of different options that are most relevant to your execution. And then it can also execute, Terraform. So, a safer way to kind of execute Terraform would be to do it in Terraform Enterprise and not give the model like that power to change your infrastructure without any sort of human in the loop or control, right? So creating plans, workspaces, all those kind of things gives you a lot of power, a lot of action. So, what's next? So as we evolve, more and more kind of in the AI space, there's the idea of a custom slash command. Custom slash commands allow users to kind of define their own kind of workflow. And that could involve tools, that could involve using tools or MCP servers, all that kind of workflows. But if there is a specific workflow you're looking for, you can define that as a custom slash command. So let me kind of show you a real quick kind of version of what that looks like. So I'm going to start sharing my screen. I pre-recorded this one just so that I have it ready and I don't have to. Let me make this full screen. Let's just start this. Hopefully the audio is heard.
Hey there, sorry to interrupt. We actually cannot hear the audio. I just wanted to let you know so that our participants could see it.
Got it. Let me voice over it. So essentially what I've done is I've created a custom slash command here. And I've defined what that slash command means. So the slash command here means I want to analyze my Terraform. So if I want the agent to be able to, after we saw how it generates the code. After it generates the code, I want it to run Terraform plan and figure out what I'm actually deploying and analyze that workflow. Analyze like what am I actually trying to deploy? What is the risk? Like if I create this infrastructure today, like what is the risk that I'm taking by creating this infrastructure? So as you can see, like Bob is kind of looking into a few different files, trying to read and trying to understand. And it created this really nice summary for me of what I'm trying to deploy. So you can kind of see, okay, it gives you a risk analysis. Okay, here's the infrastructure risk analysis. here are the medium impact, high risk impact, and really gives you a really nice analysis of like, if I deploy this S3 bucket right now, what are some of the considerations you should have in order to really make this a practical deployment. So we'd already adhered to some of the CIS policies, but it kind of noticed that some of the other policies were missing. So that's custom slash commands. That's pretty new in how these tools work. Let's go back to the slide. So we saw that. And then what's out in the horizon is HashiCorp Agent Skills. So we created a repository. Anthropic has released another standard and given it to and made it public and community driven now, called Agent Skills. And the idea with Agent Skills is that you can give the models everything it needs in terms of like instructions, tools, slash commands, plugins, all those kind of cool features in a bundle so it can perform a particular task or particular use case. So you can define that use case and the agent can just run with it. So what we've been doing is we've been publishing HashiCorp agent skills. So for example, how do you develop a new Terraform provider, or how do you write a Terraform module, or how do you run acceptance tests on those providers? The repository was made public 2 days ago, so it's very, very, very new. It lives under HashiCorp /agent skills on GitHub. But what makes it really powerful is in those definition of those instruction files, we tell the agent exactly how to troubleshoot some of those operations, right? Like if you run into a commonly faced errors, like how does a human would troubleshoot it? And an agent having those powers make it really, really powerful, right? We also focus on controlling verification gates, like PR reviews, like and giving it access to only the relevant tools and relevant even within the MCP server. There could be tens of tools defined, like 40, 50, 80 tools defined, right? But maybe to perform that specific task or perform that specific action, you only need 5 of those tools. Like you don't need all 40 or 50 of them. And you can define what tools the agent would need in these files. So it's a collection of skill files for all of our different products, starting with Terraform, Packer, soon going to add Vault. And these are specialized instruction files that can really help with AI assistant development. And so at last, thanks for joining the session and watching the presentation. If you want to get started with our tools, here's the QR for all of our MCP servers that are out there. Scan this QR and get started. It's very easy to get started. It's a simple Docker container that can run in your environment and really kind of make you very powerful when you're in your AI usage with Terraform. It's also free and under MPL license, so there's no like license or anything like that attached to it. Free to download and open to use. Cool. Awesome. Thank you so much. And have a great rest of your day. Hopefully you learned something valuable today.